Loud.
All right.
Awesome. So I'm here with Ben on the infrastructure team, and we're going to dive into Grafana. You want to take it away, Ben? Or
Sure. So maybe we should start with a little bit of the beginning, which is the actual Prometheus infrastructure underneath our Grafana instance.
so this is kind of like the time series data store that the metrics live in, and then
this is the monitoring system and time series data store. So with Prometheus, we're not just collecting data for visualization, we're also collecting data for alerting. And so all of our production alerting monitoring is driven by Prometheus data. But we can be very data driven in our approach to what is actually the root cause of a problem. We can get that from our data.
Neat. Are in terms of how you configure the alerts, is that done through Prometheus? I'm not super familiar with it.
Yeah, so the Prometheus monitoring system has a number of components. The core center is Prometheus, the Prometheus server, and it's basically a data collector, a time series database, and an API. Mm-hmm. And the API provides a query language to get to the data that you've collected. So it has all the data, it stores it, and then you can query it from that single source of data. Mm-hmm. And so each Prometheus server is an independent running, what we call non-coordinated cluster. Mm-hmm. So it is a scalable, clusterable solution that doesn't require node-to-node coordination, so that if there's problems on a single node, it doesn't affect the other nodes.
Gotcha. And does it shard data across that cluster, or do you hit theoretical issues or real issues with data size and limits on?
Yes and no. Yes, there is. So there is sharding, but you tend to shard vertically and not horizontally. Because horizontal sharding, again, requires coordination. And coordination on a network is fragile. If you've ever run a Cassandra or MongoDB, you know that it has a tendency to blow up. And so we do a little bit of, we do a little bit of trickery and different way of thinking in the Prometheus ecosystem in order to deal with the sharding and high availability.
Gotcha.
There is a concept of horizontal sharding, but you'd have to be Google in order to actually have a big enough system to need that for a single application. Because part of the idea is an individual Prometheus server node is so easy to deploy and so scalable that you can deploy hundreds of them. And so it's designed to be modularized down to, you have one Prometheus and one app, and one Prometheus and one app. And so it's designed to be hyper sharded, so that's one-to-one with an app. And so you'd have to have a single application that is so big that it requires horizontal sharding before you would even need to start thinking about that.
Gotcha. It's fascinating. Thank you. And in terms of I had another question about alerting. How do you go about configuring those alerts, or is it kind of individual static thresholds that you're configuring, and how does that, or is there any kind of anomaly detection or more approaches like that?
So there's the configuration of Prometheus for alerting is all done through what are called rules, and rules are basically continuously executed queries. And so you can ask you can say you've got a bunch of data on memory usage, and you can ask the cluster, what's the average memory usage for this process across my fleet? But you can do more complicated things. You can say you have 100 servers, and you want to make sure that the average across the fleet is okay, but you also want to make sure that you don't have any individual instances that are not okay. And you also want to check to see are there some instances that are, say, out of bounds by, say, the 90th percentile? So you could, instead of asking for the average memory utilization, you could ask for the 90th percentile of utilization. And so you can ask all of these statistical queries of Prometheus. And what you do is you put your idea of what statistics you're interested in into the config, and then Prometheus will continuously run that query for you. And based on your threshold or your idea of what's wrong, it will then fire an alert.
And who does that? Like SREs, I'm assuming. But could you talk about the process for if you need to create an alert? How do you determine you need it and then go about creating it?
Sure. So we have a general, and so the GitLab SRE team follows some of the what are called the use method or red method, and that's we actually typically don't look at like what's the memory utilization of our servers. We look at the latency for our application, we look at the error rate of our application, and we look at the saturation of our application. And so we're looking at these golden signals, as they're called. If you read some of the various papers, or the Google SRE book, for example, talks about the things that you want to alert on are the things that matter to your users, not what matters to the operating system. Because the operating system is the data that you're getting from the operating system is not intelligent enough to express your business need, which is, I expect my Git commit to happen in 1 second on average. So we don't. So we have these signals, and we have them standardized across all of our services, and that's all checked in. So from a simple logistical perspective, all of our data rules are all checked into a Git repo, and then those rules are automatically synchronized up to our Prometheus servers. So and Prometheus automatically picks those up and acts on them.
Gotcha. What's the name of that repo?
Runbooks.
Runbooks. Okay. And you were saying that the runbooks in general in the group are pretty good, pretty solid.
Yeah. So we have this idea that everything that has to do with paging and alerting and on-call should all live in the same place. So say we have a new service that we're turning up. We add some new alerting rules for that service, but we also want to add the documentation for what to do for that service. So that's all can be done in one merge request. Or say we're going to change the threshold. We document the threshold. We change the threshold. We document why, and then we document any changes to the runbooks, or to the troubleshooting playbooks for our production, and say we update any dashboards that need to be updated when we add that new service. And so the dashboards are also in the same repo. The runbooks and the troubleshooting guides and the how to fix production is all in this one big runbooks repo.
That's fantastic. And that would be what you're referring to. Say if you're a SRE and something's going wrong, you get an alert, you go to the runbook. Maybe that's a good segue to kind of dive in a little bit. If I don't know if you're able to screen share, but
sure,
I'd love to see you start. I mean, we can start with an alert, start with a runbook, or start with a graph. But it'd be great to kind of see just how you flow through that process. And I'm sure I'll have questions about.
We'll start right here with my calendar. So here is here's like one of our templated dashboards, and so this is an automatically generated from GitLab.com runbooks.
So the configuration of the dashboard itself is actually stored as code in here as well.
Yep. Awesome. So if we go into here, we can see that this is the general metrics, general service platform metrics. And if we scroll down this, there should be a service dashboard. Or was there a general directory? Yes.
There's yes.
There's general, and then there's is it this one? Yes.
Okay, and this is the Grafana.
So this is a templating thing called GraphoneNet, and it uses a language called JSONNET to compose dashboards through a templating system. And so you can, it's
similar to JavaScript, but I'm assuming a little more limited in what you can do.
No, it's a domain specific language. It's called JSONNET. And JSONNET is a data templating language that was inspired by Google's internal data templating language called Borg CFG.
We are the Borg.
Yep. And so this was a data templating language that was used, or it's a data templating language that was inspired by the need to configure jobs running in Borg. So basically the same thing as Kubernetes. So there are some people that are using this same templating thing to configure their Kubernetes jobs instead of using something like Helm, because Helm is not very powerful in terms of language expression. So it's this has a much more powerful language expression to actually do function programming and other types of input and output. So you can.
And so it seems like you're positive, like this is a nice interface to configure these dashboards through.
Oh yeah, instead of having to go and edit because the raw JSON, instead of having to click around here, and of course clicking around is never reproducible. And say I want to change I want to change the line type, or say I want to change these variables, and this stuff at the top here is shared between multiple dashboards and multiple services. So this is inheriting stuff from multiple template layers. And so there's this general graph panel, and this is a graph panel new, and it contains this data source, and all of these things are all templated, and it just pulls in add template, add template, add template. And so this whole entire complicated dashboard with all of these graphs, huge thing. This is all coming from yeah, so this node metrics detail row, this one add panel generates all of this stuff.
So you can generate add a lot of complexity in here. I had a question actually, since you're on it. I was wondering when I was in here the other day, the graph with the kind of baselines around it there.
Yeah.
The green area. How do you it looked like those were labeled low normal, high normal. How do you what's used to calculate those?
Yeah, so let's take a look. So if we go into the edit mode and
so that's requests per second against this service that we're looking at.
So this uses average over time last week. So in Prometheus, you can request something. You can request offset 1 week, and so we can see upper normal. And so in our data, so we don't in Prometheus we explicitly don't have any anomaly detection, as it were. But there are practical, simple standard deviation anomaly detections that you can do that are significantly less computationally intensive than some people's attempt to do magic anomaly detection. And so we program these things in by looking at the standard deviation, and so we have we have these recording rules. And those are all in the runbooks. So if we go back to the runbooks, there's a couple of blog posts and some other documentation on what's called practical anomaly detection with Prometheus. And if you search for those keywords, you'll find this stuff. And this is all generated through our are these service recording rules. So if I can find, let me see if I can keyword this into my source code right here. Oh, look, I'm in the right directory. Yes, so this is in service ops. Service ops rate. And so what we're doing is for each service, we have these recording rules and we create these component operations rates. And we get this from, say, Redis commands to processed. And so this is a recording rule elsewhere in our rules. And we take that and we get this by this environment tier and type, and then we stick that into this recording rule. And so this recording rule is now generic. And we move the labeling up to here. And so we can actually go to, say, oops. Here, and we can see all these components, and we can see type Redis. And so here,
and this interface that we're looking at now, so this is not Grafana, this is a UI.
So this is raw Prometheus. So this is this is basically the Prometheus debugging console. And so here is a pre-recorded data of the overall full rate of our Redis requests per second. And so we're doing something like 30,000 requests per second on the production Redis.
It's a good clip.
And and so that and this is Prometheus G prod. And we can also look at Prometheus G stage, and we can see its staging environment is only doing 1.3 thousand requests per second. Now the fun part, so we'll come back to Prometheus in a second. So we're recording the rate, and then but we're recording it generically for every service. And so if we scroll down here, you can see this component operations per second average over 1 week. So what we do is we generate an average over 1 week and a standard deviation over 1 week. So we take a whole week's worth of data in Prometheus and we figure out what the standard deviation is over that, and we record that as a separate piece of data. And so now, if we go back to Prometheus,
and that's what we're looking at there is 2 standard deviations from the mean from an average of a week, of the full week, or of some time slice of the week that correlates with the present.
The full week from the previous week from the present.
Gotcha. Interesting. Well, you mentioned performance, other types of, related to other types of normal or anomaly detection. Have you hit issues with that where there were queries that had performance issues or maybe weren't advisable to be running because of that type of concern?
Well, so yeah, we've had we have a lot of different dashboards, and so we've had to go and create these recording rules to summarize out 1 week, because Prometheus I can ask for this right now, and Prometheus will go and calculate that. But if you want to graph a whole 1 week standard deviation, that's going to be stupid slow, because it's going to be pulling in millions of samples into memory and trying to do a live calculation on that. So we actually, so we pre-record this, and we only update this back into time 1 week every 5 minutes. Just to make sure that we don't overload the Prometheus server with these huge, long 1 week calculations.
Gotcha. Do you have this gets a little meta, but how do you monitor the Prometheus server?
Well, so every component, so the standard thing in Prometheus is we have this thing called a metrics endpoint. And the metrics endpoint is just a simple HTTP API that when you say get metrics, it dumps all the current state of all the data. And
Mhm.
this is a standard API that every Prometheus target uses. So if we look at targets in our production environment, you can see that those are probes, but we don't care about probes. Why are we still looking at probes? Let's look at something more interesting. So here we go. So here is 9101. So that's cAdvisor. So here's data coming from cAdvisor. We can't actually click this because it's on our internal network and we can't get to that, but you can see that we'll reach in and get this data out of our internal 10net, and this will print out a thing. And if we go to something like prometheus.demo.do.prometheus.io, and we say up, we can see something like one of these things, like a port 9100. So if we actually just copy and paste that, we'll see that, well, this is the root level. And if we click on giving you the metrics, there's our Prometheus metrics endpoint. And it's just a simple text output. And Prometheus can ingest this stupid fast.
Awesome. Jumping over to Grafana, maybe, could you, sorry, go ahead. Yeah.
But you want to know about the meta monitoring. So
yeah,
Prometheus itself, sure enough, Prometheus produces its own metrics. And so if we look for rule evaluation group intervals, we can see this metric, Prometheus rule group last duration seconds. And so let's go back and ask Prometheus itself to let's do, that returns 780 metrics. That's a little noisy. We wanted to know about this one, which was this one. So I think if we, so if we have this rule group, and if we go up here and we filter for this rule group string, and we say, let's only look at one Prometheus server since we have, let's look at one Prometheus server. Okay, so now we've narrowed it down to one metric, and now we can graph that. And we can see that most of the time this rule evaluation takes it's pretty quick.
200 milliseconds, or that's an average of the operation.
Yeah. So the say the 90th percentile is somewhere in the 200 millisecond range to do that 1 week calculation across all instances of that metric.
Interesting. Awesome. Thanks for that.
And so that's how we can meta monitor Prometheus.
Awesome. Could you talk a little bit about, say if you were to try to answer the question, like, how are things going in production now? Or are there any problems, in production, kind of how you would approach looking at that if you're just trying to get a sense of it?
So we have some of these like big general dashboards that tell us SLA trends on various services, give us our overall SLA, things for our front-end services, web front-end, API, Git, the CI runners, the container registry. So all these big public dashboards.
Is it typical if I noticed some of these are still loading up. When you're in here, do you find it, are you frequently waiting for graphs to load, or are they usually pretty snappy?
Sometimes, yes. There's a bunch of optimizations that we're needing to make this stuff faster. So one of the things that we were talking about is we were talking about the fact that you might have hundreds of Prometheus servers. And so GitLab has not hundreds, but dozens. We've got about 20 or 30 or so, I think. Mm-hmm. And that number is growing as we expand. And in order to view all the data all at once, so we were looking at this one Prometheus server. Mm-hmm. In front of Prometheus, we've actually got a proxy system called Thanos. And so if you go to Thanos and we look at the stores, we can see all of the backend Prometheus servers, and also what are called, so there's different backend types. There's the sidecar, and these are attached to the individual Prometheus servers. So we've got like a Prometheus server running in GKE in Kubernetes. Mm-hmm. We've got these other ones that are just running in regular Chef management. And then we've got these rule evaluation servers, which we can get to later. But then we also have these things called a store server. And the store server is, so one of the things that we do is we have this thing in Thanos that takes Prometheus is constantly scraping data, storing in its time series database. And then what happens is it writes that data to a local disk every 2 hours. So every 2 hours, ka-thunk, a big block of data hits disk. And mm-hmm. The Thanos sidecar takes those 2 hour blocks of data. Those are immutable. Basically, once Prometheus has written that data, it's just done. That data is read-only. It's not an updatable database like a SQL database. And it takes those 2 hour blocks and just stuffs them into object storage. And so now we've got 2 hour blocks of data in an object storage. And so instead of asking Prometheus to go and get this data way back months or years, we can ask this store component to go do that for us. And the mm-hmm. store component pulls in the data that is uploaded into GCS, pulls it down, and serves it up to Thanos so that we can do queries way back in time.
Gotcha. Okay, and we're using GCS. That's Google's object store.
Yeah, or? Google's object storage. You can use S3, Azure, Minio, Ceph, whatever. There's a bunch of different options there.
Awesome.
And so that's how Thanos lets us tie all of this Prometheus infrastructure together to scale it up.
Mm-hmm. And that's where then on some of those high level dashboards, some of the performance issues can come in because
because we're having to hit a large amount of data from Thanos, and so we're in the middle of trying to optimize these queries and improve the performance of Thanos and make it so that these dashboards are more reliable.
Mm-hmm. Is that the infrastructure team as a whole doing that, or are there
specific people? We have a subgroup of infrastructure that is focused on observability, and so we're working on, we're working on expanding and improving the Thanos performance. We're working on expanding our Elasticsearch infrastructure, and we're kind of trying to come back and look at observability from a high level perspective.
Awesome. I know we're kind of up on time here, but anything else you feel like is worth sharing or I should have been asking about?
Let me give you some fun numbers. So from the ops environment, we monitor all of our Prometheus servers in production. So there are now, so the number is 22 right now. And so you can see how many, what are called head series is how many current metrics are we tracking. So if we take and just do a sum of the head series, we get a high level number of
29 million is
29 million individual metrics. Mm-hmm. And then, but that's deduplicated between all of our high availability instances. So in Prometheus, we have high availability where there are two Prometheus servers just both doing the same thing. They're configured identically. They have slightly different data in the time series database, but they're operating independently. Mm-hmm. And if we execute that, we have 58 million metrics.
58 million metrics, yeah. Do you know how much, how many bytes that works out to, or?
Well, bytes over time. I was just doing some auditing of our production database for all of the production side GCS data which covers the last year of raw metric data plus downsampled data for the last 5 years, we get to about 26 terabytes of metric data, which is in the Prometheus compressed format.
Yeah, it's quite a bit.
Yep.
Cool. I really appreciate you taking the time to go through this with me. Maybe we'll do it again sometime if you ever are free, and I'd love to just pick your brain more about this stuff.
Yeah, if you ever have more specific questions, feel free to book time.
I'm sure I will. Yeah. So I appreciate that. So yeah, enjoy your evening, and thanks again, Ben.
Yep. Have a good day.
Oh yeah. See you later. Bye.